Hi everyone. So today I'm going to talk to you about the second derivative test. And if you're already aware of this test naturally, you can feel free to go on ahead because this screen essentially shows everything I plan to talk about. Okay, so here we go. So as you can see, we have this function, f of x, right? And you can tell that there are two critical numbers, one here and one here, because these are essentially places where the first derivative is 0. Or you can see that there's a relative max and a relative min here. So the second derivative test is useful because say you don't have a graph of the function like you do here. Then you can discover, well, whether or not there's a relative maximum or relative minimum algebraically. For example, the second derivative test says that if the second derivative at c, which is in this case, let's say here, actually let's say it's here, and if it's greater than 0, then there's a minimum at c. So what that means is at this point, the slope, as you can see, is getting bigger, right? So the second derivative is increasing. Therefore, there must be a minimum at this point. So the curve, in fact, kind of looks a little bit like this, because you can see that the slope is constantly increasing. However, if the second derivative is less than 0, then there must be a relative maximum at c. So here you can see that the slope goes down. In other words, this curve kind of looks concave down, or like this. So the slope over time is decreasing. So there's also a third case, though, for the second derivative test. Namely, if it's equal to 0, then the test fails. You don't learn anything. You're not sure if there's a relative max or a relative min. So I pay special attention to this case, guys, because this does come up in tests. Thank you, though, and hope you're having a great time of day and have a wonderful time in calculus.